Hello everyone, मेरो नाम सञ्जीव सिन्जाली currently studying at Softwareika College of IT and E-commerce in partnership with Coventry University. My Softwareika ID is 230524 and my Coventry University ID is 148111933. I'm presenting this video as part of my Viva assessment for the module Data Science for Developers. The aim of this project was to use data science technique to support property investment decision. For this project, all data sets were provided by our teacher and my role was to clean, analyze and interpret the data using R programming. The study focuses on comparing two UK counties, Cheshire and Cumberland, to identify which towns are more suitable for property investment, especially for international investors who may not be familiar with local conditions. Rather than relying on intuition, this project follows a data driven approach and evaluates location using three key factors: house price to measure affordability, broadband speed to represent connectivity and support remote work, crime rate to reflect safety and quality of life. These factors together give a more realistic view of property investment potential. Data cleaning. A major part of this project involved data cleaning. This includes removing duplicate records, handling missing values, correcting data formats, and mapping postcodes to towns. Data cleaning is essential because unclean data can lead to misleading analysis. By cleaning the data properly, the accuracy and reliability of the results were provided improved. House price. House price data was sourced from the UK land registry dataset provided for the project to avoid distortion caused by extremely high property value. Median house prices were used instead of average. This allowed a fair comparison between towns and helped identify areas that are more affordable while still offering future investment potential. Broadband is broadband speed. Broadband speed data was taken from Ofcom dataset. In today's digital environment, fast and reliable internet is critical, particularly for remote work. The data was clean and aggregated at town level, and average download speed was used as the main indicator of connectivity. Towns with higher broadband speed were considered more attractive and future ready. For the crime rate was sourced from UK police and home office datasets. Crime rates were calculated relative to population size to ensure fair comparison between towns. Lower crime rates were scored higher as safety plays an important role in liability, community well-being, and long-term property value. Exploratory data analysis EDA help identify patterns and trends using charts such as bar charts, line graphs, box plots, and scatter plots. Linear regression models were also used. The result shows that areas with better broadband connectivity generally have higher house prices. Higher crime rates tends to reduce property values. This supports the idea that connectivity and safety strongly influence investment decision. These are the charts that I got from the R code. For the recommendation systems, using 2023 data or recommendation system was developed. It combines house price with 40% weight, broadband speed with 30% weight, crime rate with 30% weight. Towns were ranked based on combined score, and only towns with sufficient data were included to ensure accuracy. The results show that although Cheshire had the top ranked town, many high scoring towns were located in Cumberland, proving that balance factor can outperform price alone. At last, in conclusion, this project demonstrates how data science can be used to support informed and ethical property investment decisions. Instead of focusing only on affordability, the analysis showed that connectivity and safety are equally important. The recommendation system provides a clear data driven guide for investors and can be updated regularly as new data becomes available. And now for the code, we have cleaning broadband speed data. For cleaning broadband speed data, I first rename the columns to make them easier to work with, remove any missing or zero values, and filter the data to include only relevant postcode areas. I then aggregated the data by postcode to get average and maximum download and upload speed. This ensures the broadband metrics are accurate and ready for analysis. Now for the run, it will show broadband coverage for the for the cleaning crime data. In cleaning crime rate data, I renamed columns, removed invalid records, and aggregated the number of crimes by type and postcode. This process ensures that the safety information for each area is reliable for further analysis. This is the code. Now I'm running it. Now it will shows yes. For cleaning population data, I removed inconsistent or missing records and aggregated population figures by postcode. This provides accurate demographic context for per capita calculation and other analysis. Now I'm running this code, and now it's here. For cleaning house data, when cleaning when cleaning house price data, I removed mm, invalid or missing records, standardize the column names, and calculate average prices by postcode. Thus, this prepares a clean data set for studying affordability and trends in housing price. Now we have house price 2020 for 2022, for 2023, and now 2024. For linear modeling, I examine correlation between house prices, broadband speed, and crime rates, and fitted regression models to understand the impact of these factors on housing prices. This provides a quantitative way to predict prices based on other variables. These are the codes for the linear modeling. Now I am running it. Now it is here. Now for the recommendation system. Finally, in the recommendation system, I scored and ranked towns based on house price, broadband connectivity, and crime rates using weighted criteria. This approach offers actionable suggestions for choosing towns that are safe, affordable, and well connected. I'm running it. Okay. At last, for the EDA exploratory data analysis, I visualize the dataset using graphs such as box plots, histograms, and bar charts to explore distribution trends and relationship between variables. These steps help identify patterns, detect outliers, and support insights for decision makings. Now it runs. Now for the graphs, I have some graphs. This is for score breakdown for top 10 towns, house price and house price versus download speed, and these are the graphs that I got from doing EDA. At last, thank you.